Good morning. Today is a good lesson in Algebra 2 because a lot of our lessons are rather theoretical and mathematically based in that you don't see immediately where they are useful in life, but this one you get to see an application of polynomial functions and how you could use it to make decisions, to help you make more money, and that's very useful. So our activity today is on Next Lesson. That's the screen that I have up here. Now I put on an announcement on, I believe it was November 7th, that had you enter a class code, which was unique for each class period on this site. So if you have not done that, you need to go find that announcement and do that. So pause this video if you need to, go do that. If you are just doing that now, you will need to email me and let me know because there's a step that I had to do between when students joined and when you can see the activity that if you waited to join until now, I haven't been able to do for you. So let me know and I will add the activity for you. And next time follow directions. So anyway, so when you go on nextlesson.org, you're going to go to My Lessons. Yours might look a little different than mine since mine is teacher version. You won't have all of these things. You should just have home value, I think, showing. Or if you don't, let me know and I'll add it for you if you were a late join. So let me switch this over to student view here. Okay, so what we're going to be looking at is if you are a real estate developer, let's say you're going to flip houses and you want to figure out which city you should work in to maximize your profit by doing so. How can we use the data about recent home sales in order to make a prediction of which place is going to be has the biggest potential for growth? So that's what we are looking at here. So now the navigation buttons are here along the side. So I'm going to hit the next page button so that we can see level 1. So we're going to do level 1 on the first day of this activity and level 2 on the second day. So what we have here on level 1 is we have a table of values, and it looks like we have home values from the year 2006 until 2015 for 3 different cities. We have Columbus, Ohio, Cleveland, Ohio, and Cincinnati, Ohio. So I have the Columbus data graphed for you, so I'm going to show you that on Desmos, and I am sharing that file with you. So you have that one that you can use, and it's already done. And if you will save that as different names on Desmos, you can just change the home values for the Cleveland and the Cincinnati data. So that will speed up your process a bit here. So what we're going to do is number 1 says use the table to determine polynomial models for each city. So we're going to look over here. So I have my data for Columbus. These are the Columbus house prices. Notice for the X values, I put 06 for 2006 and 07 for 2007 because it said to use t equals 0 to represent the year 2000. So that's why I have just 06, 07, 08 like that. And if you look, I don't see any data. But do you remember the little magnifying glass that's over here? If I click that, zoom fit, okay, there's my house values. So we can see that the house values had a bit of a dip in them, but they're on the rebound right now. So when you were in 8th grade in middle school, all you knew about basically was lines. And this clearly is not making a line, but I'll go ahead and show you what it would try to look like. Like it would be like, okay, fine, if you want me to fit a line to it, I'll fit a line to it. And that's what we would get. This is not a good fit for what is happening in this data. So I'm going to turn that one back off. So, oh yes, I should point out the way that you tell Desmos, which we've done this before, to make a line of best fit is you say Y1, and if you remember, the 1 is there so that you are telling the computer to pull the data from this column where the Y1 is. So Y1 is approximately equal to, so this symbol is above tab, so it's up by escape on my keyboard. MX1, and you put the 1 after the X for the same reason we did after the Y, to tell the computer to pull the data from the X1 column here. So then if that line is not a good fit, maybe I want to fit a parabola to it. So I am typing in what would be standard form of a quadratic. So you're thinking y equals ax squared plus bx plus c. But notice we have the 1s to tell the computer which data to pull from. So let's turn that one on and see how it looks. So like it's a little bit better than the line, I guess, because it's showing the fact that there's a rebound, but I don't think that's really a very good fit. So I'm going to look at what the cubic would be. So I'm typing this cubic. Here, I'm going to turn the quadratic off for a minute. Turn the cubic on. So I'm typing the cubic also in standard form, so you're thinking y equals ax cubed plus bx squared plus cx plus d. So the a and the b and the c and the d will be numbers. They're the coefficients, or d is the constant on the end, in front of each of those terms, but I don't know what they are, so I want the computer to tell me what they are, and it is. I'll show you that in a minute. Okay, so I feel like that's a much better fit than this quadratic, because it's just staying closer to the points better. Here's how the computer judges which one is a better fit. Do you see this r squared line? I can't really highlight it, so just see where my cursor is there. R squared equals 0.85 on the red one, and then down here on the blue one it's 0.9532. So you can think of that as kind of like the decimal form of a percent ranking. Like this is like an 85% fit on the red one versus a 95% on the blue one. So the higher the better. You want to get close to 1 is what you're going for here. So that red one, you can see visually, it's just not as good of a fit. So I'm going to turn that one off. But maybe I should use a higher polynomial. So I went ahead and typed in an x to the 4th polynomial here. So I'm going to turn that one on. And it actually looks almost the same. So there's the purple one. That's the one with the 4th power. It looks almost the same. And when I first looked at this one, I was like, uh-oh, something's wrong. Because if it's to the 4th power, what type of end behavior should we be seeing here? Both ends should go the same direction, shouldn't they? Because even exponents, even degrees, make that happen. We talked about that with end behavior. So I was like, uh-oh, something's going on here. And when I zoomed way out, I was like, okay, it does end up going back down in the end. But here, let me get my data zoomed nicely again. But we really don't care about that far out on the data. You would only use a curve of best fit to make a prediction about just the next couple of years. You would not be looking at what housing prices are going to be like in the year, 2050 or something, because we don't know what's going to happen between now and then. Our model is probably not going to still be in effect that far out. So you would just make predictions about just a couple years around this. So anyway, these two, the cubic and the 4th power polynomial, are so close that I think it doesn't matter which one you use. Now for the other cities that you're going to do, if there's a clear winner, go with the one that's better. But like if I look at these r squared values, they're almost the same. So I'm just going to go with the cubic. Okay. So if I look where it says parameters here, so remember I said that the a and the b and the c and the d are the coefficients in front of those terms. The computer is telling me what a and b and c and d should be. So a is the number 165. So when I write my equation over here on next lesson, that's what I'm gonna put. I'm gonna put, for Columbus, I'm gonna put y equals, and I'm gonna put the 165 in front of my x cubed. Okay, so that's how you're going to type that. Plus, and then I'm going to look back over here and get my b value, which my b value is the negative 4,793. I'm just going to round that. That's fine. So, minus 4,793 is in front of my x squared. Let me see what my C value is. The C value is 40,864. 865 I should round to. 40,865. So plus 40,865 x plus, what's my D value? 11,322, we'll say. 11,322. Okay, so that's how you'll type your equation in for what you feel is the best fit. And if you don't pick the same one as somebody else, that's fine. You're using your judgment. That's where professional judgment would come in on this. So I've done Columbus for you. You're going to do Cleveland and Cincinnati. Oh, I should show you this on Desmos while I'm thinking of it. So up here, I have a save button because I could save the changes that I've made. If you log into Desmos, you should be able to save this, and it should allow you to duplicate or rename it. So I would duplicate it and then name it the other two cities, and then just change the Y column here to reflect the value of the houses in those cities. So that would be the easiest way for you to do this, because that way these regression models are already typed in for you, and you can just turn them on and off at will. So there's that. Okay, let's see what question number 2 says. Assess the fits of each model with the data. Does one of the city's models appear to fit the appear to be the best fit? So our cubic and our fourth power were really close. So we went with the cubic. It fit much better than the quadratic, that was the x squared, and the linear one, that was the y equals mx plus b one. And I could give evidence of my r squared factors because it was higher on the cubic or the fourth power one. So for 3a, so you'll do that for the other two cities. I just talked about Columbus, you talk about the other two. For 3a, it says, based on your models, describe the function in terms where it's increasing and decreasing and where there are local maximums and minimums. Okay, so increasing is where it's going uphill, where the house values were rising, like from a certain time frame, like from 2006 to whenever, like when were the houses rising? And then where did you see a decline? Decreasing means it's falling. So give me time frames on these of when the house values were going up or going down. And then the local maximum would be a high point. A local minimum would be a low point. And then do you expect the home values in each city to be increasing or decreasing in the near future? So for this activity, 2016 would technically be in the future when I'm looking at those numbers in the table. I know this data is just a couple years old, so I apologize for that. So think about 2016, 2017. Do you think it would be higher or lower than what you're seeing in the 2014-15 data? And base it on your graphs. Don't just guess at this. Okay, and that is everything that we're going to do for level 1. So I'll go over level 2 in the next video. So make sure that you save your work. There should be a button that says Save Draft up. Mine's in the upper right-hand corner, so I think you'll have that as well. And then I'll tell you tomorrow where I'll tell you now. The turn-in feature is under Table of Contents. It will say turn in answers at the end, okay? So you don't need to do it today after level 1. We'll do it tomorrow after we do level 2, but I wanted to show that to you now. So, okay, I think that's everything. So remember that Jesus loves you, and so do I, so do your math.